This on real quick. Does anybody have any questions though from homework or anything? Anything that you guys want to go over? Mhm. Okay. Okay. You got time. You got time. You got this weekend.
Yeah.
Yeah. Yeah.
That's the thing I gotta be.
Oh no. Sorry. You know. Yeah.
Every day.
Yeah.
And not one. Bang.
Nah, in the future, I'm not gonna do that. I'm not gonna do that double homework thing in the future, but
Like 6 exercises, I was like, oh my God, fine.
got you.
Big four,
Yeah.
53. That was
Yes, that was a lot.
Hey, you like-
That was a lot. So you know,
I got a pass because
yeah,
you combined, we combined it with a scientific notation,
yeah,
but still, that was rude.
because they're the same topic, you know. So like, what I used to do, like when I was a student, I would like you see how the World Cup is on right now, so I'll have the World Cup playing, and then like every time there's a commercial or something, I'm banging out math problems. So I don't want to watch the beer commercials and all that, you know? And as soon as they come back, boom, you know?
Actually,
Hey,
watch cartoons while I'm doing my homework.
that's the best.
Yeah,
That's the
and it's
best.
so
Yeah.
cool for,
Yeah.
yeah.
I like to listen to music when I'm doing my
Watch.
yeah. So for me, right, when it comes to math, like I need like reggae, right? But when it comes to coding, I need bachata. I don't know why. Yeah. The thinking is quicker, like Yeah. All right, if there's no questions, we're gonna on Monday. Yeah, yeah. I got you. I got you. Yeah. Monday's lesson is gonna put all of that together. All right, real quick, real quick, real quick. Let's do a quick recap. How I do this real quick. Oh, I done made that too big. No, that's fine. So I have 7/10 plus 8/15. I didn't realize that was that big. You could tell I wear glasses, right? So I have 7/10 plus 8/15. What should I do first? Yes, I got to find my LCD. What's my LCD here? 5? That's my greatest common factor. What's my LCD?
5.
Uh-uh.
That just said 5. Um,
It's 30, right?
yeah.
So I need a number that both of the denominators can go into, right? Easy way to find the LCD, take the biggest number that you have, right? In this case, the 15, right? Does 10 go into 15? No, right? So double the 15. 15 times 2 is 30. Now, does 10 go into 30? Right? So that's how I find the LCD. Take the biggest number, right? And then just if the next other number doesn't go into it, double it times 2. Does it go in now? It doesn't? Okay, times 3. Does it go in now? Okay. Does it? All right, times 4. Just keep doing it like that until you get a number that the other number goes into. So always start with the biggest. That's my way of doing it. So now what should I multiply the 10 by to make it into 30? By 3, right? But you know what I do to the bottom? I do to the top. What should I multiply the 15 by to make it into a 30? By 2, right? But what I do to the bottom, I do to the top. So now, what do I have? I have 7 times 3 plus 2 times 8 over the 30, right? Let's multiply these together. This is 21 plus 16 over 30. Let's call that 31, 37 over 30. All right. Is there any questions on this? All right. So after we multiply our numerators, we just add them together and we're good to go. All right. This is how we add fractions. Right. That's literally the whole lesson for today. So if you understand that, you can just start the homework. But yeah, yeah, you especially because you're really talented. Like, yeah. I feel like after I say like 3 words, you probably get understand and you could just finish everything.
It's the same.
Hmm. It's the exact same. So check out this question. Nothing's different here, right? I want to find the LCD, right? So once again, right? Start with the largest number, 9. Does 4 go into 9 evenly? No, right? So double it. 9 times 2, 18. Does 4 go into 18 evenly? No. Okay. Let's triple it now, right? 9 times 3, 27, right? Does 4 go into 27 evenly? No. All right. Times 4. All right. Does hold on, 18, 36. Does 4 go into 36 evenly? Good. All right. So now 4 times what is 36? 9, right? And what I do to the bottom, I do to the top. 9 times what is 36? 9 times what number is 36? 4, right? And what I do to the bottom, I do to the top. After that, just multiply it, right? What do we have? We have 9 times 3x minus 8 times 4 all over the 36, right? Let's do the math on that. 9 times 3, 27x minus, oh, I'm going to struggle with this one. 8 times 4, what's that? 8 and 8 is 16, like 32, right? All over the 36. And that's it. Because there's a sum or a difference here, and they're not like terms, you just leave it the way it is. And you're done. Questions on this?
Oh,
Sure.
okay, got it.
We good? Sure, sure. There you go. You're welcome. All right, so let's check out another one. Oh, baby. Who remembers how to do this? Or you could just tell me how to do it and I'll do it out. Mhm. Distribute, right? So what am I distributing? Very good. Very good. The whole thing. Proud of you. All right, so 6 times 2x, that's going to give me a 12x. Plus 6 times 1, let me check on the calculator. That's 6, right? Yeah, that's the hard one. That's the hard one. Then we have negative 4 times x. It's going to give me a negative 4x. And then negative 4 times negative 5, that's a what? Let's see. Good. Positive 20. And then now I want to combine like terms, right? So tell me what to write. Very good. And that's 8x. Very good. And then what's 6 plus 20? Good. Plus 26. And that's it. That's my answer. That is it. Yeah. That's what we're doing today. Easy. Yeah.
I'm going home.
Nice and simple. See, if it was me, I wouldn't even leave with homework every day. I would be done with everything. Yeah. But once you, I don't know if you realize this, right? But I do like a lot of examples in class, but I'm just repeating the same thing again and again and again. So like I'm saying, once you get it, you could just be here, just you know? Yeah. All right. It is the same with rational expressions. To add rational expressions, they must have, excuse me, to add rational expressions, they must have a common denominator. When the denominators are the same, you add the numerators and place the sum over the denominator, right? So this is how to add rational expressions. So rational expression addition and subtraction. If P, Q, and R are polynomials where R cannot equal 0, then P over R plus Q over R is equal to P plus Q over R. And, right, for subtraction, P over R minus Q over R is going to be equal to P minus Q over R, right? That's it. The exact same thing with the numbers. So to add or subtract rational expressions with a common denominator, you add or subtract the numerators and place the result over the common denominator, right? Let me make sure I got my button, okay? We always simplify rational expressions, so be sure to factor if possible, right? After you subtract the numerators so you can identify any common factors. Remember too, we do not allow values that would make the denominator 0. That's illegal. So what value of x should be excluded in the next example, right? Oh, baby. So let's try this out, right? Do I have the same denominator here? Right? So because I have that, I can just add the numerators. So this is going to become what? 11x plus 28 plus x squared all over x plus 4. Just like that. Go ahead. Nope. Just add the numerators and that's it. Right? Let me rejumble this a little bit, right? I'm going to make this x squared plus 11x plus 28 over the x plus 4, right? Now, let me ask you something. What value of x is illegal here? Which one? Not x squared. So remember, it's illegal for me to divide by 0, right? So what value of x would make the denominator 0?
Minus.
Exactly, right? So start off with that. You have x plus 4 is equal to 0. We're going to solve for x, subtract 4, subtract 4. So when x is equal to -4, right? This is your excluded value. I'm sorry? So I could plug in for this rational expression, this fraction. I could plug in any value of x except -4. Anything else is fine, right? But at -4, the denominator becomes 0 and then it's undefined. It's not legal, right? The last thing we should do is we should factor our numerator, right? Help me out. I need two numbers that when I multiply them together will give me a positive 28. But when I add them together, will give me a positive 11. What are they? 10 and 14? 7 and 4? Let's see. So plus 7, plus 4. Let me think. Let me think. 7, 14, 28. Good. 7. Yep, that's good. All right. All over the x plus 4. Do I have a common factor in the top and bottom? All right, so I could cancel those out. So what's my final answer at the end of the day? It's just x plus 7. And that's it. Huh? That's it. We found our excluded value, which was x equals -4. We factored and simplified our fraction, and that's it. That's the whole process. Questions on this? Mm-hmm. Yeah. Okay. On your homework, they might ask you for that. They might say, "Oh, what value of this sum or this difference for the rational expressions would make the denominator zero, or what number is illegal or whatever," right? So you just set the denominator equal to zero, and then you give them that number. X equals blah blah blah. Or if that doesn't work, then you might just have to put in like -4 or something like that, and that's it. Hmm? You guys want to try one, or can we move on? Up to you guys. One more can hurt? All right. All right. I don't have no instructions here, but here's what I want you to do. You're gonna you're gonna give me the excluded value, and you're gonna give me the sum and simplify it. Mhm. You did it right. Yay. Let me know when you guys are good. All right. Let's try this out. All right. Do I have the same denominator? Yes. All right. So now all you have to do is just add the numerators, right? So this becomes 9x plus 14 x squared all over the x plus 7, right? Let's shuffle that around. This is going to give me x squared plus 9x plus 14, right? All over the x plus 7, right? So now let's figure out what our excluded value would be. Tell me how I can do that. Mhm. Exactly, right? Set the denominator equal to 0. So x plus 7 is equal to 0. Just solve for x. Ow, right? Good. -7, right? So I'm going to subtract 7, subtract 7. So x is equal to -7. That is your excluded value. That's for your homework, right? And now just factor the top, factor the bottom. Top is what? X plus 7 and x plus 2, something like that. Over the x plus 7. Do I have a fact on the top and the bottom? That's alike. Good, right? So let's cancel these out. So now what am I left with? X plus 2. That's my final answer. That's it. Questions on it? All right, all right. So let's try subtraction. Even though you all already know what to do, like just humor me for a second. Mhm. Same kind of question. Okay. So I got 5x squared minus 7x plus 3 minus 4x squared plus x minus 9, right? Over the x squared minus 3x minus 18, right? Do I have the same denominator? Awesome, right? So now this becomes what? 5x squared minus 7x plus 3 minus, parentheses, 4x squared plus x minus 9 all over the x squared minus 3x minus 18, right? After that, let's distribute, right? You want to distribute that negative to everybody. So now this becomes what? 5x squared minus 7x plus 3 minus 4x squared minus x plus 9 all over the x squared minus 3x minus 18. Let's combine like terms, right? Combine like terms. 5x squared minus 4x squared is 1x squared, right? And then negative 7x minus x is negative 8x. And positive 3 plus 9, that's like 10, 11, 12, right? All over the x squared minus 3x minus 18. Now, let's find our excluded values, right? So I'm going to take my denominator, which is x squared minus 3x minus 18. I'm going to set that equal to 0, right? Then we're just going to factor this. What's this? I should know this. What's that? 6 and 3, maybe? So I'm thinking x minus 6 and x plus 3, something like that, right? Is equal to 0. Set both of these equal to 0. So x minus 6 equals 0. Add 6 to both sides. So x1 is equal to 6. And then we have x plus 3 equals 0. Subtract 3 to both sides. So x2 is equal to 3. Put a little comma. These are my excluded values. So just a quick recap, right? That's minus 3, by the way. Just a quick recap, right? I could plug in any value of x that I want into this rational expression except these two values right here, right? In web work, they might ask you to list out the two values, just write the number, then you write comma, then you write the other number, right? And then that's how you do it. Sometimes they ask you to do that without a space. So just to let y'all know about that. Anyway, let's continue with this question, right? I want to factor the numerator. So this is going to be what? X minus 6, x minus 2, something like that. And the bottom is going to be what? X minus 6 and x plus 3, right? Because we did that already. Do I have a common factor in the top and the bottom? Right? So I'm going to cancel that out. What's my final answer? X minus 2 over x plus 3. Perfect, right? And then let me just box that, and that's it. Questions about subtraction, anybody? Let me go back up to the top. The idea is you're going to distribute the negative onto every term to the right. Then you're going to combine like terms and you're done. Right? You guys know to find your excluded values, you just set the denominator equal to 0 and that's it. Let's make a special note here, right? Whenever I'm finding my excluded values, notice that I do that, right? Before I simplify the fraction. Make note of that, right? I find the excluded values before, right? I simplify the fraction. So that if you simplify the fraction first, you might be tempted to say, oh, the only excluded value is -3. It's also +6. It's both of them. All right. Because if I plug in +6, that denominator becomes 0. All right. And 0 over 0, that's also undefined. All right. Anytime you divide by 0. All right. We feel good, or do y'all want to try one? I could go up real quick. Yep. And that's the bottom. Yeah. All right, I'm gonna move on because I'm taking your silence like y'all understanding. So this is gonna be a really, really, really interesting concept right here. All right. Me? All right, so check this out, right? I'm going to add and subtract rational expressions whose denominators are opposites. Oh boy, here we go, right? So when the denominator of two rational expressions are opposites, it is easy to get a common denominator. We just have to multiply one of the fractions by -1 over -1. Let's see how this works. Let's say, for example, I have 7 over d plus 5 over negative d, right? So to make that negative d positive, I'm going to multiply by -1 over -1, right? Just like this in the red, -1 over -1. When that happens, this becomes what? 7 over d plus -5 over d. Combined like terms, 7 minus 5 is 2 over d. Questions about this? So when the denominator is an opposite, right, you just multiply by -1 over -1. The negative is going to carry over to the numerator, and the denominator is going to fix it, and it's going to be able to match the other denominator. And then you do what you have to do after that. Let's look at an example real quick. What happened? Oh, I got you. Let's look at an example real quick, right? So I have m squared minus 6m over m squared minus 1 minus 3m plus 2 over 1 minus m squared, right? So now I notice that my two denominators are opposites, right? So what am I going to do? I'm going to multiply my numerator and my denominator by -1. When I do this, this is what happens, all right? So this becomes m squared minus 6m. Hold on one second. Over the m squared minus 1 minus, right? And then I'm going to distribute this -1 to all the terms here. This is going to be what? -3m minus 2 over the m squared minus 1. Now, because the two denominators are the same, I can just subtract the numerators and that's it. So this is what? This is m squared minus 6m minus, open parentheses, -3m minus 2 all over the m squared minus 1. We're going to distribute that negative to both terms here. So this is going to become what? M squared minus 6m plus, right, 3m, and then plus 2, right? All over m squared minus 1. Let's combine like terms. What do I have? I have m squared minus 3m plus 2 all over m squared minus 1. Let's factor this, right? All right, we really should find the excluded value. Let's do that first, right? So the excluded value, this is m squared minus 1 is equal to 0. You're going to add 1 here. So m squared is equal to 1. Square root both of these, so m is equal to 1. Right? That's your excluded value. Now, let's continue. Let's factor this, right? So the top, this is going to be what? M minus 2, m minus 1. On the bottom, this is what? M plus 1, m minus 1. Do I have any like terms here? Right? The m minus 1, right? Cancel that out. Here's your final answer. M minus 2 over m plus 1. And that's it. Questions on this? Anybody? I started up here. So that's the rule for whenever we have the denominators that are opposites, right? Rational expressions are opposites, right? You multiply by -1 over -1. Because the idea is that if you think about it, -1 over -1 is just 1. So I'm kind of just multiplying this fraction by 1, for lack of a better term, right? And when I do that, it eliminates, well, not eliminates, but it makes this denominator match the other one, the other term's denominator, right? So after the two denominators match, I can subtract as needed. Boom, right? And that's it. And then excluded value, just set the denominator equal to 0, solve for the variable. And then, of course, factor top, factor bottom, whatever's left over. That's your answer. Y'all good, or y'all want to see another one? All right. Don't worry, I got more. But before we jump into any more, though, I just want to give y'all some notes real quick, all right? So we want to find the least common denominator of rational expressions. So when we add or subtract rational expressions with unlike denominators, we will need to get common denominators. If we review the procedure we use with numerical fractions, we will know what to do with rational expressions, right? So let's look at this example, 7 over 12 plus 5 over 18, right? Since the denominators are not the same, the first step was to find the LCD, the least common denominator. To find the LCD of a fraction, we factor 12 and 18 into primes, lining up any common primes in columns. Then we brought down one prime from each column. Finally, we multiplied the factors to find the LCD. When we add numerical fractions, once we found the LCD, we rewrite each fraction as an equivalent fraction with the LCD by multiplying the numerator and denominator by the same number. So we are now ready to add, right? All right, so 7 over 12 plus 5 over 18. LCD is 36. 12 times 3, what you do to the bottom, do to the top. 18 times 2, what you do to the bottom, do to the top. So it'll be 21 plus 10. Call that 31 over 36. So here's our notes, right? How to find the least common denominator of a rational expression. Step 1, factor each denominator completely. Step 2, list the factors of each denominator, match the factors vertically when possible. Step 4, write the LCD as the product of the factors. All right? And that's it. Excuse me. Questions on this from anyone? It's just the notes, that's all. Mhm. So we got a little instruction on this question. So it says find the LCD for the expression 8 over x squared minus 2x minus 3 and 3x over x squared plus 4x plus 3. Rewrite them as equivalent rational expressions with the lowest common denominator. So what should I do first? Starts with an F. With an F. Huh? You're gonna factor each denominator, right? So what does this become? This is 8 over. It's gonna be x and x. Two numbers I multiply to give me -3. So -3. So and we have the 3x. This is gonna be what? X plus 3, x plus 1. All right. So we factored our denominators, right? Now say we want the LCD of these two denominators, right? We want like whatever is missing, right? So let me elaborate on that real quick. So for the first term, right, I have 8 over x minus 3 times x plus 1, right? So if I add in x plus 3, what I do to the bottom, I do to the top. And if I add in an x minus 3, what I do to the bottom, do to the top. After that, you already know what's going to happen. Distribute. That's 24. And then this would be distributed on that. This is 3x squared minus 3x. Of course, you should greatest common factor at the top, right? We're not adding or subtracting. These are just like list numbers. So this will be 8x minus 3. And then over here, factor out the 3x. Excuse me. This is 9x here. Factor out 3x. What's left over? X minus 3. And that's it. You can cross out like terms. I feel like I'm missing something here. 1 second. Okay. Cross out the like terms. Mhm. So that's what's left over. I have 8 over the x plus 1 times x plus 3. The computer might want you to simplify first before giving the answer. And I have 3x over um that's it. Questions on this? Find the LCD for the two of them, simplify it down, and then you're good to go. Sure. This particular question, I want you to take note, it does not have an addition or subtraction to it. This is purely just finding the LCD. You're gonna have some questions like that where they're just gonna ask you flat out, what is the LCD? And that's it. You're welcome. We good? All right. All right, just humor me with this next question. I'm aware that you all know how to do this. Well, if you want, y'all could try this and then I'll do this in a minute. All right, let's take a look. I had a minute. So now look, I have 3 over x minus 3 plus 2 over x minus 2, right? What's my LCD here? What is it? Not 1. Mhm. They're both different, so all right, it's real simple, right? You have the two different denominators here. You're just going to multiply them together. X minus 3 times x minus 2. That's it, right? So, nope, just put them next to each other. So for x minus 3, right, I'm missing an x minus 2. So I'm going to multiply it by that to get the LCD. What I do to the bottom, do to the top. I have the x minus 2 over here. I'm missing an x minus 3. So I'm going to multiply it by x minus 3. What I do to the bottom, do to the top. Exactly. And that's the sauce. right? After that, what do you have? You have 3 times x minus 2 plus 2 times x minus 3 all over x minus 3, x minus 2. Simply just distribute to both terms and then combine like terms. That's it. So 3 times x, this is 3x minus 6 plus 2x minus 6 all over the same x minus 3, x minus 2. Notice I didn't multiply those, right? There's a reason. Combine like terms. This is what? 3x plus 2x is 5x. Negative 6 minus negative 6, negative 12, right? This is as simple as this is going to get. So I have x minus 3 times x minus 2. That's it. I'm done. If they ask you for the excluded value, you already know, set the denominator equal to 0, blah, blah, blah. That's it. Any questions on this? So this is literally how to add fractions. Find the LCD, make the denominators the same, right? And then what you do to the bottom, you do to the top. More often than not, this is what's going to happen though. You're going to have two different denominators and you're just going to multiply them together to give you the LCD. Simple, 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 right? This won't change. Hmm. Let me give you guys some notes real quick before we jump into another example. All right, so here you go. How to add or subtract rational expressions. Okay. Step one, determine if the expressions have a common denominator. If yes, go to step two. If no, rewrite each rational expression with the LCD, right? Find the LCD, rewrite each rational expression with an equivalent rational expression with the LCD, add or subtract the rational expressions, and then simplify if possible. That's it. This is how we add or subtract rational expressions. That's the total notes for today. I have a few more examples to go through, but you guys have enough information now to knock out your homework if you want to do that in the meantime while I'm working on these. Go ahead. There you go. Yeah. So let's start off with the first one, right? So I have 8, excuse me. Excuse me. Sorry about that. So I have 8 over, I want to factor this denominator, right? This is going to become what? X minus 3 times x plus 1 plus, this is going to be, you're welcome, 3x over x plus 3, x plus 1, right? What's my LCD here? Here's the easy way to find the LCD. Take one of the denominators. It doesn't matter which one. I'm going to take the first one because I'm lazy. So I have x minus 3 times x plus 1. Look at the second denominator, right? The second term with the denominator. I already have a x plus 1, but I don't have an x plus 3. So put the x plus 3, right, on the LCD, and then that's it. This is your LCD. Not too bad, right? So now we want to make each one of these denominators the same, right? So I have an x minus 3 times x plus 1. I'm missing a x plus 3. But what I do to the bottom, I got to do to the top. In the second term, I have an x plus 3, I have x plus 1. I'm missing an x minus 3. But what I do to the bottom, I got to do to the top. And after that, you already know what's going to happen, right? This is going to become what? 8 times x plus 3 plus 3x times x minus 3, all divided by the LCD, which is x minus 3 times x plus 1 times x plus 3. Distribute this onto both terms, right? Distribute onto both terms. So now what does this become? 8x plus, what's that, like 24, right? Plus 3x squared minus 9x. Then I want to combine like terms, right? Bear with me 1 second. X plus 1, x plus 3. Okay, so now I want to combine like terms. 1 second. Awesome. So now what do I have? I have 3x squared. 8x minus 9x is going to give me a negative x, right? And then plus 24. All divided by the x minus 3, x plus 1, x plus 3. Let's factor this numerator. I'm going to have what? 3x over here, x right here. I need two numbers that multiply to give me 24. Trying to think about this. Mm, this is going to be negative. Bear with me 1 second. I'm just trying to verify, make sure I'm not losing my mind. Mm-mm. All right, I'm looking at this. This really can't be factored. So that's my final answer. Sorry about that. Hmm? But these things happen sometimes. It can be factored into something, but we haven't learned the technique for that yet. However, we will. It's coming. Okay. Let's see what else we got. Let's take a look at this example. All right. So in this example, I have 8y over, this is going to be what? Y plus 4, y minus 4, minus the 4 over the y minus 4. So LCD is y plus 4, y minus 4. I'm going to multiply this by y plus 4. You want to make the denominator the same, which is the bottom to the top, y plus 4. And then you already know, this is what? 8y minus 4 times y plus 4 all over y plus 4, y minus 4. Distribute this. This would be what? 8y minus 4y minus 16 all over y plus 4, y minus 4. This will be equal to what? 4y minus 16 over the y plus 4, y minus 4. Keep it going. Let's factor out a 4. This leaves me back with y minus 4 over y plus 4, y minus 4. Cross out your like terms. Final answer, 4 over y plus 4. Here we go. Questions on this? Same old, same old. All right? Doing the same topic again and again. Let's try another one. I got like 3 more examples and then we could call it. These won't be bad examples, I promise. Just showing you like a variation, different ways that the question could come at you, even though it's the same process again and again, right? So let's take a look at the first one, right? So I have negative 3n minus 9 over, this is going to be what? N plus 3, n minus 2, right? Again, if you see me factoring out a quadratic, you're wondering how to do it, AC method will always work for you, right? It'll work for all of them. I'm using shortcuts because of time, okay? Minus, okay? N plus 3 over 2 minus n. Watch what I'm going to do for this though, right? Because I noticed that these are opposites, right? N minus 2 and 2 minus n. So what am I going to do? I'm going to multiply this by negative 1 over negative 1, right? This little trick is going to make them the same, right? So you want to distribute this. Boom, boom, right? So I have negative 3n minus 9, right? Over the n plus 3, n minus 2, minus, this is going to be what? Negative n minus 3 all over the n minus 2. Now, to get the same denominator, all I have to do is multiply this by what? N plus 3. What I do to the bottom, I got to do to the top, n plus 3. After that, it's easy. A little distribution and we're done, right? So this is negative 3n minus 9 minus, open parentheses, negative n minus 3, n plus 3. You know what? Let me put this in brackets just so we can see. That's because that's what's going on. All over the n plus 3 times n minus 2. All right, let's do some magic on this, right? So this is negative 3n minus 9 minus, open parentheses. This is going to be a negative n squared minus 3n minus 3n minus 9, close parentheses. Let's combine like terms. This is n plus 3 times n minus 2. Combining like terms, I have negative 3n minus 9 minus, open parentheses, negative n squared minus 6n minus 9. All right? After that, you want to distribute that negative to every single term. Bear with me 1 second. Okay, so we're going to distribute that negative. So negative 3n minus 9 plus n squared plus 6n plus 9 all over the n plus 3, n minus 2. Let's combine like terms. And what do I get? I have n squared plus 3n minus 0. all over the n plus 3 times the n minus 2. Let's factor out an n. This becomes n times n plus 3 over n plus 3 times n minus 2. These will cancel. Final answer, n over n minus 2. And that's it. Of course, if they want the excluded values, you know to set the denominator equal to 0, solve for those two numbers, blah, blah, blah. Questions on this? The trick here, I was given opposites from the beginning, all the way up here. So I multiplied by that -1 over -1 to get rid of the opposites. After that, it was straightforward. LCD, right? What you do to the bottom, do to the top, right? And then we just subtract going forward, which just involves distributing, combining like terms, and our final answer is n over n minus 2. Questions on this? All right, let's keep it going. Actually, you know what? This is going to be our last question after this, right? So, last question right here. Not too bad, right? So, I'm going to factor the first one. So, I have 4 over what? A plus 5, A plus 1, minus 3 over A plus 5, A plus 2. LCD, A plus 5 times A plus 1 times A plus 2. This first term is missing an A plus 2. What you do to the bottom, you do to the top. The second term is missing an A plus 1. What you do to the bottom, you do to the top. Let's distribute, combine like terms, get our final answer, and then we're good to go, right? So this is going to be what? 4A plus 8, right? Then we're going to distribute minus 3A minus 3 all over the A plus 5, A plus 1, A plus 2. Combining like terms, this be, oh shoot, hold on. That's supposed to be an A. Sorry about that. Anyway, combining like terms, right? This should be what? A plus, what's that? 5 all over the A plus 5, A plus 1, A plus 2. Cross out the like terms. Final answer, 1 over A plus 1 times A plus 2. That's it. Questions on this? All right, let's call it at that. That's it for today. May I take this down? Or is anybody still copying? This is being recorded. I will post it. You're welcome. So we good? I can take it down? All right, I appreciate y'all. So just come up and sign out before you leave.